All right, hey guys, this is day 0 of our stats unit. So this is a little review of statistics that you did in Algebra 1. So this first part, when it's saying distributions are described by the shape symmetric or skewed based on what you're seeing, this goes back to like doing bar graphs, which you probably even did before Algebra 1, probably in middle school. So like this first one, you can see that they're giving you the numbers like 1 through 5, and then the frequency of how often they're showing up. So 1 shows up 1 time. 2 had 3 times, 3 showed up 6 times, and so on. So when you see the different shapes that can happen, so like here you see where it's mounted in the center, here it's the same across. So when it says, the distribution has the mound shape, all right, and it's symmetric and it has just that single peak, like this one here, this is what we'd considered mound shaped, whereas here we would call this like a uniform shape. All right, so I'm just going to draw like a line across the top. So even though it's not perfect, it's the idea that you can kind of see what's happening. So this one is more uniform, whereas this one is more mounded in the center. All right, so you can kind of see that type of shape going on there. All right. If a distribution is skewed, that means it might lean one way or the other. So in this case, if it's skewed right, it means it's got like a longer tail to the right. So if I was to trace over this, you can kind of see that it extends and there's a bunch of data off to the right-hand side, which is why it's saying it's skewed to the right. Versus if it's skewed to the left, you get the gist of how this works. Then if I were to kind of trace over the shape, the longer tail would drag out to the left-hand side, all right? So this part, the mean of the distribution, saying is interpreted as a typical value or the average value. So you guys remember mean, median, mode from back before. I feel like that's what everybody at least remembers from stats. And that's a good thing because you still need that, all right? So the idea, sorry, I'm trying to get it to focus more and it doesn't seem to want to. That's the idea that, that mean value, when it's mounted in the center, is typically right in the middle here, all right? It's often represented by the symbol. This guy right here, this is called X bar. So it's literally referred to as X bar, like that. Right? That represents the mean value, all right, or the average of the data. All right, the next part, the standard deviation. This one, typically the calculator will calculate it for you or it'll be given for you. So you don't have to worry about how to calculate the standard deviation. You just have to know how to use it. So it's saying it's a value that describes the typical distance from the mean. So how far away the data is from the average. So if the standard deviation is a big number, it means the data is really spread out. If it's a small number, it means all the data is really close together. All right. It's saying it's often represented right here with the little sigma, this guy, for the entire population, or S sub X here for the sample population. And you're going to see those two things on the calculator. All right, so I'll do it a little bit bigger. So sigma or S sub X, like that. All right. All right, on to the back of the notes here. We have a little example to take a look at. It's saying you're given a histogram. So that's what all a bar graph is. That's all a histogram is just a bar graph here. That shows the distribution of the greatest drop in feet of 55 major roller coasters. So it's kind of fun. So they're saying the maximum drop, so like the biggest drop on the ride. So anywhere from 50 to 90 feet falls here, 90 to 100. You can see here's 130 to 170. And then they've got a couple that fall way out here, 290 to 330 feet, 410 to 450 feet. I actually like roller coasters, but there's no shot you'd be getting me on those two. So that's fine. All right. Over here, when it says the relative frequency, you can see it's out of decimals. So if you added all these frequencies up, the total would be 1. So when you see the frequency like this, the total would be 1.0, sort of like a probability was for the last unit. So you can see like a little bit more than a quarter, or in this first part, like, a little more than 30% or here, and so on. So it says, would you describe the distribution of the roller coaster maximum drop as approximately symmetric or skewed? So if you trace kind of over it, it's not all mounted in the center. If it was mounted in the center, we'd say symmetric. So in this case, we would say skewed. And more specifically, I would say skewed to the right, all right? Because there's more data off to the right of the highest peak, all right? right, is the mean of the maximum drop distribution closer to 90, 130, or 240? In this case, without actually like calculating it, you just want to look and say, okay, where does it look like the middle is? We're just eyeballing it, to be honest with you. So 90 is right here. 135 would be like here-ish. 240 would be up here. So you're looking for where's the one closest to probably the middle, right? I would actually say that it would be the 135 in this case, because if we stop at 90, think of the frequency there. It was only 0.25. You've only covered a quarter of the roller coasters. It's not until you get to here where you've covered about half, a little bit more than half of the roller coasters, that I would say that you're probably going to hit the mean. Right? So I would say that the middle, value is about 135. Right. Part C, is the standard deviation of the maximum drop distribution closer to 40, 70, or 100 feet? All right. In this case, standard deviation, we're talking about how spread out is the data. This one, you can kind of make your best estimate. So what I want you to think of it is if we're saying that 135 is the middle, so right about here, how far out captures a good chunk of the data, like the middle chunk of the data? So if I go to the left and right, 40, if I go to the left 40, it would cover from like here to here, which is a small amount, right? If I go left and right 100, it would go all the way down to here and then all the way up to like here-ish, which covers an awful lot. So I'd probably go right in the middle, going up and down about 70, all right? So it's kind of like Goldilocks. This is a little bit too small. This one's a little bit too big. This is just right, all right? So I would say the main chunk, all right, of data is within 70 feet of the mean, which we said was about 135-foot drop. All right. And like I said, don't worry about calculating that in the future. We will show how to calculate it in just a second here on our actual calculators. So this last part says, following are the number of calories in a basic hamburger. Okay. With one meat patty, no cheese at various fast food restaurants around the country. All right. It says input the data into L1 on the calculator. So stat, edit, enter, and then use the one variable stats to do it. All right. So you can quick take a minute to do this. As a reminder, it's saying right here, stat, and then hit edit. If there's anything in there, and I have stuff in here from before, you can go up top and just hit clear. Just don't hit delete. And then you can enter the data in. All right. So you can go through and enter each one in. Just type carefully and then double check your list when you finish, right? So if we run through, I forgot this one was on here. Otherwise, I would have typed it in already so that you wouldn't have to wait for me. Oops. And 680. And I do want to get these in here just so that you can accurately see the numbers show up. So give me just another 30 seconds and I'll have all of this in here. Okay, so I believe I've got all those in there. All right, so now it says input the data in. We're done with that. Use the one variable stats to calculate the mean and the standard deviation. All right, so as a reminder from the first page, the mean is the X bar. The standard deviation, since this is just a sample of the fast food restaurants, we're going to use the S of X here. So when you go back to your home screen, you're going to go to stat, and then let me zoom in a little bit so you can see. Stat, go over to calculate, and then the very first choice is one variable stats. So you're just going to hit enter. It should already have L1 in there. So as long as you typed everything into L1, don't worry about the frequency. We don't want that for this. So if there's anything there, get rid of it. And then hit calculate. All right, and so then you're going to see a whole ton of data here. But the very first thing, X bar, that is the average number of calories. So 665, let's say, calories based on all of this. The standard deviation. So there's a bunch of other stuff here, but the S of X is the one that we want. So the standard deviation for this sample is 283 calories, right? So a good amount, and we'll talk exactly about how much data falls in between one standard deviation above and below the mean. That'll be part of tomorrow's lesson and the next day. But that's talking about like how spread out it is. So if you go 283 calories above this, 283 below, so you're talking about 400 calories to like, 900 something calories is a good amount of the numbers that you have up here. Right? Other things that if you arrow down through this, that you might remember, they give you the min value, the median, the max. If you guys remember doing like box and whisker graphs, you had the quartiles in there. We're not really going to be doing any of that within this unit, but some things that might spark your memory a little bit. So that's it for the first day.